Dear students and all other beloved viewers, you are all welcome to our channel. Today I am going to discuss about measures of dispersion. Before going to discuss about the topic, you are requested not to skip the video. If you are newcomer to our channel, you are also requested to subscribe my channel, or at the end of video you make comment, visit in the comment section. Now let us discuss about measure of dispersion, which is for the students of class 11 science students, overall for the student of statistics. Now let us to discuss about measures of dispersion. First of all, frequency distribution differs in three ways. Number one, average value. Number two, variability or dispersion. Number three, shape. Number one, average value, which is related with measures of central tendency. Mean, median, mode are the measures of central tendency, which I discussed already in our previous 2 or 3 videos. Now, number 2 point, variability or dispersion, which I will discuss about it in my present videos, which is related with measures of dispersion. There are 4 measures of dispersion: range, quartile deviation, mean deviation, and standard deviation. Last way is shape. Here will be discussed relation between average and shape of frequency distribution with the help of moments, skewness, and scatosis, which will be discussed in next 3 or 4 videos. Now let us discuss about the measures of dispersion. Now look at the board and listen carefully with great attention. An average, we get average from central tendency. An average is the representative of whole data, but average cannot tell us in what manner all the values of variable are scattered or dispersed about the average. For example, here we take 2 series, first series and second series. Each series has 5 variable: x1, x2, x3, x4, x5. Look at that. Each series has same mean, that is 4, but it does not clear the picture about the data, whole data, because all the variables, in what manner all the values of variable are scattered and dispersed about the average, we cannot get the clear picture from the average. So we have to go to the variability or dispersion. Now we consider the first series. The variation of values of x1 from x bar is 4 minus 2 is equal to 2. In case of x2, 4 minus 3 is equal to 1. In case of x3, 5 minus 4 is equal to 1. In case of x4, 7 minus 4 is equal to 3. In case of x5, 4 minus 3 is equal to 1. Now note down that variable whose value is nearest to that of average is more reliable or dependable. The variable whose value is farthest from that of average is less reliable. Here, first series x1, x2, x3, x4, 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 the nearest value is 1, 1, 1. That is x3, x2, x3, and x5. In case of first series, more reliable variables are x2, x3, x5. Okay. In case of second series, x1, 4 minus 4 is equal to 0, 4 minus 2 is equal to 2, 4 minus 3 is equal to 1, 4 minus 1 is equal to 3, 10 minus 4 is equal to 6. Here more reliable variables is x1. Here x2, x3, x5. So average does not give us the clear picture about the whole data. So we have to go to the measures of dispersion. So we can come into conclusion about definition of dispersion, that the variation or scattering or deviation of different values of variable from their average is known as dispersion. Variation or deviation different values, that is x1, 2 from their average 4, that is 4 minus 2, 4 minus 3, 5 minus 4, 7 minus 4, 4 minus 3 is known as dispersion. Clear? Next, discuss about classification of dispersion. Now we have to learn about types of measure of dispersion. There are two types of measure of dispersion. Number one, absolute measures of dispersion. Number two, relative measures of dispersion. Absolute measure of dispersion has four types: a range, which is denoted by R; quartile deviation, which is denoted by QD; mean deviation, which is denoted by MD; and standard deviation, which is denoted by SD. Relative measure of dispersion also has four types: coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variance. Please carefully note down it. So next we have to discuss about the range. So go to the range. Now let us discuss about range. It is most easy to calculate the range in case of simple series and in case of group frequency distribution. In case of range, at first we will take the largest value of variables and smallest values of variable we take. Here we see that smallest variable is 5 and largest value of variable is 10. So a range R is equal to largest largest value of largest value minus, that is L, smallest value, smallest value, that is S, is equal to, that is largest value is no 10, largest value is 12, that is 12 minus smallest value is 5, so range is 7. So range is 7. So in case of simple series, to calculate the value of range, we at first we take the largest value from the variables and the smallest value from the variable, and then we will differentiate between largest value and smallest value. That is range is equal to largest value minus smallest value. Here largest value is 12 and the smallest value is 5. So 12 minus 5 is equal to 7. In case of group frequency distribution, we will take the upper class and lower class. This is the upper class, and this is the lower class. This is the upper class and this is the lower class. Then we will take the upper boundary of upper class and lower boundary of lower class. Upper boundary upper class is 50 and lower boundary of lower class is 0. So range R is equal to upper boundary of upper class minus lower boundary of lower class. Here upper boundary upper class is 50 minus lower boundary of lower class is 0. So range is 50. Most easy to calculate range. In case of simple series, we have to take largest value and smallest value. In case of frequency distribution, we will take the upper boundary of upper class and lower boundary of lower class. Thus, this range is equal to upper boundary of upper class minus lower boundary of lower class, that is 50. So, we have to next the quartile deviation. Now it is turn to discuss about quartile deviation. After discussing the range, I am to discuss about the quartile deviation. In case of simple series, I take the data, that is 39, 12, 26, 19, 24, 36, 21, 33, 35. Before calculating the quartile deviation, we have to clear about the quartile. What is quartile? Now, I draw a straight line. That is called AB. Quartile means 4 equal parts of total part. 4 equal parts of total parts is called quartile. That is, AB must be divided into 4 equal parts. Then AB is this middle portion that is C. C is the middle portion of AB that is divided into two parts. Another two parts, to find out another two parts, we have to do the middle portion of A and C is D, and middle portion of B and C is equal to E. And that is four parts. That is 1, 2, 3, and 4. Four parts. Quartile means four equal parts of total parts is quartile. When one part is taken from total part, then it is first quartile. When two parts are taken from quartile, then it is called second quartile. When three parts are taken from part, then it is called third quartile. Then from A to D is the first quartile. It is denoted by Q1. From D to C, and at the point of C, it is denoted by second quartile, and at the point of E, from C to E, it is called third quartile. It is called third quartile. If the total length of AB is the total number of frequency, that is called N. That is called N. And it is equal part, then at the point of D is a 25%. 25%, that is 1/4 into N is equal to N by 4. And at the point of C, it is 50%, that is 1/2 into N is equal to N by 2. And at the point of E, that is 75% is equal to 3/4 into N, that is 3N by 4. 3N by 4. It is the actual position of quartile deviation. Here we consider first quartile deviation, second quartile deviation, and third quartile deviation. So quartile deviation is defined by quartile deviation. So quartile deviation, that is QD, is equal to average of difference between Q2 and Q1 and difference between Q3 and Q2. Again, quartile deviation is defined by average of difference between Q2 and Q1 and difference between Q3 and Q1. That is Q2 minus Q1 plus Q3 minus Q2, that is average divided by 2, is equal to Q2 minus Q1 plus Q3 minus Q2 divided by 2. Q2 plus minus katai vanish, that is Q3 minus Q1 divided by 2. And the definition of quartile division, we may say that the quartile deviation is the half of difference between third quartile and first quartile. That is, quartile deviation is defined by third quartile minus first quartile divided by 2. That is half of difference between third quartile and first quartile. Next, here I write a problem, a simple series, and then the question how to find out the value of Q1 and Q3. Now I will go to the to find out the value of Q1 and Q3. To find out the values of Q1 and Q3. At first, simply say we have to arrange the data in ascending order of magnitude. At first, we have to arrange the data in ascending order of magnitude. Ascending order. So, at first we take 12, then 21, no, then 19, then 21, then 24, then 26, then 29, then 33, then 35, then 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At first, we have to arrange the data in the ascending order of magnitude. Then the value of Q1 is equal to N1 plus 1 by 4 fourth term value. Here n is the nth term. Number of term. N is the number of term. And Q3 is 3 n plus 3 n plus 1 by 4 term value. Here from the given example, here Q1 is total n 1, 2, 3, 4, 5, 6, 7, 8, 9. N is equal to 9. That is 9 plus 1 divided by 4 term value. That is 10 by 4 is equal to 2 upon, that is 9th. N plus 1 by 4, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 5 and 2 upon half term value. So you have to find 2 upon half term value, that is second value, that it is equal to 2 plus half term value. is equal to second value, that is second value is 19. Second value is 19 plus the 1/2 term, that is third term minus second term. Differentiate between third term minus second term, half of third term minus second term, that is half into third term is equal to 21 minus second term 19 is equal to 19 plus half into 2, that is 19 plus 1 is equal to 20 is equal to 20, and Q3 is equal to 3 into n plus 1 by 4, 3 and 9 plus 1 divided by 4, that is 3 into 10 by 4, that is 5 and 2, that is 15 by 2, that is 7 upon nth term value, that is term value is equal to seventh term minus half into eighth term minus seventh term. Seventh term, first, second, third, fourth, fifth, sixth, seventh, that is 33 plus half, eighth term is 35 minus seventh term is 33. So 33 plus half into 2, 33 plus 1 is equal to 34. So quartile deviation is equal to Q3 minus Q1 by 2, that is value of Q3 is 34 minus value of Q1 is equal to 20 divided by 2, that is 14 divided by 2 is equal to 7, that is answer, quartile deviation from simple series. From simple series we have to do arrange the data in the ascending order of magnitude. Then Q1 is equal to n plus 1 by 4th term value, then Q3 is equal to 3 into n plus 1 by 4th term value, and then Q is equal to quartile deviation, Q is equal to Q3 minus Q1 by 2. It is a very important place. Half means that is second term, thereafter half term, second term, that is a, and this portion is total, and this total is half of this total is the term. The 21, that is the third term minus second term is equal to total part, half of the total part is half term, that is third term minus fourth term. 21 minus 19, that is 19 plus half into half, that is 19 plus 1 is equal to 20, that is Q1. In case of Q3, half, seventh term next term is 18th term minus 7th term is equal to 34 and 20, that is Q is equal to Q3 minus Q1 by 2, 34 minus 20 divided by 2 is equal to 14 by 2 is equal to 7 is the answer from the fifth a simple series. We have learned about the quartile division. Next, we have to learn about to find out the value of quartile division from frequency, group frequency distribution. In the next video, we will discuss to find out the value of quartile division from group frequency distribution. Here I will end the video, and at the end of the video you all make the comment, visit in the comment section. Best of luck.